Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Dehydrohalogenation, E2 elimination, requires an antiperiplanar arrangement of the H and the leaving group, Br. The geometry of the resulting alkene, cis or trans, is determined by the spatial relationship of the substituents in the conformation that undergoes elimination. Moving on to the next step. Identify the substrate. 2-bromobutane has the structure CH3, CHBr, CH2, CH3. For E2 elimination, we look at the Newman projection along the C2-C3 bond. C2 bears CH3 from C1, Br, H, C3 bears CH3 from C4, H, H. Moving on to the next step. E2 requires antiperiplanar geometry, meaning H on C3 and Br on C2 must be 180 degrees apart, anti to each other. And for the final step, determine which product, cis or trans, 2-butene, forms from which conformation. The two groups that end up on the double bond are CH3, C1 side, on C2, and CH3, C4 side, on C3. The relative orientation of these two CH3 groups in the eliminating conformation determines cis versus trans product. For cis 2-butene, both CH3 groups must end up on the same side of the double bond. This means in the reacting conformation, the CH3 on C2 and the CH3 on C3 must be on the same side, SYN gauche to each other, while H on C3 and Br on C2 are antiperiplanar. Newman projection where front carbon, C2, has CH3 at top, H upper left, H lower left, and back carbon, C3, has CH3 upper right, Br right, H lower right. Here the H on front, C2, and Br on back. Re-examining in option A, front has CH3, H, H and back has CH3, Br, H. The H on C2, front, lower left, and Br on C3, back, right, checking dihedral, lower left front versus right back is approximately 120 degrees apart, not anti. Front carbon C2 has CH3, top, H, upper left, H, lower left. Back carbon C3 has CH3, upper right, Br, right, H, lower. For antiperiplanar elimination, we need H on C2 at bottom, 180 degrees from Br on C3 at top, but Br is at right on C3. The H on C2 at lower left is roughly anti to CH3 on C3 at upper right. The H on C2 at upper left is roughly anti to H on C3 at lower. Neither H on C2 is perfectly anti to Br. However, for option A, the conformation shown has the two CH3 groups, C1 methyl on C2 at top and C4 methyl on C3 at upper right. They are gauche to each other, 60 degrees apart. When H on C2 and Br on C3 back are anti, the CH3 groups being gauche means they will be on the same face of the double bond cis 2-butene. In conformation A, rotating to make H on C2 anti to Br on C3, the CH3 groups on C2 and C3 end up on the same side of the developing double bond, giving cis 2-butene. This matches option A. Option B would give trans 2-butene because in that conformation the two CH3 groups are anti to each other when H and Br are antiperiplanar. Options C and D are either eclipsed or have incorrect antiperiplanar arrangements. Therefore, the correct answer is A. Therefore, the correct answer is option A.